Okay, we are going to pick up this second part with synthetic division. And synthetic division can be really helpful, especially when you're dividing by a linear binomial, such as x minus a. So if your divisor is x plus some number or x minus some number, there is a shortcut to doing long division instead, and it's called synthetic division. And this is kind of a weird setup and a weird process, but once you get the hang of it and you get the initial setup, everything should be pretty good to go. Now it says here, for the divisor, we want to reverse the sign. This allows us to add instead of subtract. So for example, if you were dividing by x plus 2, you would want to do synthetic division with the solution -2. Equally, if you had x minus 5, you would want to do synthetic division with the solution +5. So let's put this into action. Let me show you what this exactly looks like. It says use synthetic division to divide the following polynomial. What is the quotient and what is the remainder? So the first thing I'm going to do is I notice I'm dividing by x minus 7. So I'm going to take the solution and I'm going to put it in this little half box just to separate it from the rest of the numbers. So then from here, I'm going to take my coefficients of the rest of my polynomial. Now you'll notice here, there's no x squared term, and just like we did with long division, let's use that placeholder of 0 for the x squared term. So I have 1, 0, -57, and +56. And then I'm going to leave a space, and I'm going to draw a line. Now the first thing we do is bring down that first term. We always bring down the very first term. And then from here, I'm going to take the 7, and I'm going to multiply by that 1, and that number goes underneath the 0. So 7 times 1 is 7, and as the last slide told us, we're going to add down. So 0 plus 7 is 7. And then again, I'm going to do the same thing. 7 times 7, again, we're going to multiply, gives me 49, and I add down, so that gives me -8. And then same thing again, I'm going to take the 7 and multiply it by the -8. That gives me -56, and I add down, that gives me 0. Now this last number, we're going to also put that in a half box, and that number is our remainder. So now, knowing that piece of information, we know that x minus 7 is a factor. And then also, what do we know about 7? 7 is a solution. So if it wants us to, we did the remainder, we need to find the quotient. The quotient comes from all the numbers that you have underneath the line. So let's look at our original equation, x to the third power. I divided one of the solutions out, so now I would have x squared as my highest power plus 7x minus 8 with a remainder of 0. So you can think of it as like, this is your remainder, this would be your constant term, your linear term, your quadratic term. But I just remember it as if it's always going to be one less than your highest power. You could do the exact same process with long division and you would get the exact same answer. Let's try that again. On this problem, we have x cubed minus 14x squared plus 51x minus 54, and that's divided by x plus 2. What's the quotient and what's the remainder? So again, I'm going to start off with looking at my divisor, that's x plus 2, so I'm going to put -2 in my half box, and then I write my coefficients for the rest of my equation. I'm going to leave a space and draw my line, and I'm going to bring that first term straight down. So -2 times 1 gives me -2, and I add going down, that gives me -16. -2 times -16 gives me positive 32. And I add down, that gives me 83. And then I'm going to take negative 2 times 83. That gives me negative 162. And I add down to get negative 216. Yeah, negative 216. So my quotient would be x squared minus 16x plus 83, and my remainder would be negative 216. So let's answer a follow-up question here. What do we know about x plus 2? This is not a factor because my remainder was not 0. And then what do we know about negative 2 then? This is not a solution. It takes a couple of tries to get the hang of it in the setup, but once you get it, it's so much easier if you can use synthetic. So one more here, we have division with x plus 4, so I'm going to put negative 4 in my half box, and then I have 1, negative 7, and 20. So again, I'm going to draw my line, and I'm going to bring my first term straight down. Negative 4 times 1 gives me negative 4, and I add down to get negative 11. Negative 4 times negative 11 gives me positive 44, and I add down to get 37. And then I take negative 4 times negative 37. That gives me negative, what is 37 times 4? 144? 148? 148? All right, so then I have a remainder of negative 128. So I would say my quotient is x squared minus 11x plus 37 with a remainder of negative 128. And it says here, determine whether the given divisor is a factor, and it is not a factor because our remainder is not 0. All right. So what's the point in doing synthetic division? Okay, why do we do it? Well, from 5.3 the other day, we asked you to find all the real zeros of a graph. And when we did that, we saw that it only crossed the x-axis one time. But we know by the fundamental theorem of algebra that there are 3 solutions. So we talked about what were those other 2 solutions then? Those other 2 solutions were imaginary. Now that we know how to do synthetic, we can apply synthetic division and get the equation down to a quadratic, and we can solve for those imaginary solutions. However, we cannot do this without our calculator. So let's grab our calculator and type our equation into y equals x to the 4th plus x cubed minus 7x squared minus 9x minus 18. Okay, so now we're going to hit graph. And we notice here that it crosses the x-axis in 2 places. So those look pretty obvious. Let's go to the table. And we notice that one of them is at 3 and the other solution is at negative 3. So we have negative 3 and positive 3 as our real solutions. But we know, due to the fundamental theorem of algebra, I should have 4 solutions. So what do I know about those other 2 solutions? They are imaginary. So what we're going to do is we are going to synthetically divide out negative 3 and positive 3 in order to get this down to a quadratic so we can solve with the quadratic formula. So let me move my steps over here so we can keep up with the work. So I'm going to take one of the solutions. It doesn't matter. I'll just take the negative 3 one first. All right, and I'm going to do synthetic division. So I have 1, 1, negative 7, negative 9, negative 18. And I draw my line. So bring the first one straight down. Negative 3 times 1 gives me negative 3. Add down, negative 2. Negative 3 times negative 2 gives me positive 6. I'm going to add down. That gives me 3, and I add down. That gives me 18, and I add down. Now, obviously, I should get a remainder of 0 because we saw that negative 3 was a solution. Okay? Now, this is where it gets a little tricky. From here, you're going to take that second solution, and you're going to do synthetic division again with respect to your new values that you got here. The 1, the negative 2, the negative 1, and the negative 6. So again, we're going to bring that first term straight down. 3 times 1 gives me 3, 1, 3, 2, 6, 0. All right. So, as I mentioned earlier, we started with 4 solutions, right? Well, we divided one of them out, and then that gave us our cubic equation here. When we divide the second equation out, or the second solution out, we get down to a quadratic. So this is x squared plus x plus 2 now. And now all I have to do is set that equal to 0 and solve with using the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. So I get x is equal to negative 1 plus or minus the square root of negative 7 all over 2, and that reduces to negative 1 plus or minus I square roots of 7, and they're each over 2. So now, when we ask you to find all of the solutions, this is how you're going to go about it. You're going to graph it, see where it crosses the x-axis, synthetically divide those solutions out. The goal is always to get it down to a quadratic and then solve by using the quadratic formula. So let's look at problem B here, and we're going to do the same thing. Find all of the zeros for the following equation. So let's go back to our calculator, and let's go to y equals, clear out what you got there. X cubed minus 11x squared. X cubed minus 11x squared plus 43x and then minus 65. And then let's graph it. Okay. So we can see here it only crosses the x-axis one time, and it crosses at 5. So what I'm going to do is I'm going to synthetically divide out 5. And that makes sense, right? Because our highest power is 3. So it only crossed at one real solution. So that means the other 2 are imaginary. Because remember, imaginary solutions come in pairs. So we're going to do synthetic division with the 5. So that's nice. We only have to do it one time. So we bring the 1 straight down. 1 times 5 is 5. That gives me negative 6. That gives me negative 30. That gives me 13. That gives me positive 65. That gives me 0. So I'm going to use x squared minus 6x plus 13 is equal to 0. And I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. So I have here 6 plus or minus something over 2. 36 minus 52. I have no idea what that is off the top of my head. Let's go to the calculator. 36 minus 52 is negative 16. Perfect. Okay, so that's the square root of negative 16. So that would simplify to 6 plus or minus 4i, and everything is divided by 2. So our 2 final imaginary solutions are 3 plus and minus 2i. So again, is quadratic formula going away? No, it's still here, and it's here to stay. Now the last thing is what we like to call the remainder theorem. And the remainder theorem is a very quick way for you to figure out what your remainder is for a specific factor or a specific solution. So there's a lot of stuff going on here, okay, but if you want to, just don't even look at it because it's very confusing. We're going to tell you what to do here, okay? So on this last problem, it wants you to evaluate P of -4. Well, in Module A, the very first day, we talked about evaluating. So what you're going to do is you're going to plug in -4 for x into your equation, and whatever you get out is your remainder. So let's type this in our calculator. It's going to take a minute. And let's figure out what this simplifies to. So we have -4 to the 5th power minus 3 times -4 to the 4th power minus 28 times -4 to the 3rd power plus 5 times -4 and then plus 20. So we got out 0. So what that means is this number is your remainder. Now, what does that tell us? That means -4 is a solution. And then also that tells us x plus 4 is a factor. So all you have to do is substitute in to find out what your remainder is. That's the remainder theorem. All right, we hope you enjoyed 5.4. If you have any questions, please feel free to bring them to us.